All right. So today I want to talk a little bit about the SpeedTest websites, fast.com, speedtest.net, those. And it really came about because I get a lot of questions on those. And it usually sounds something like, I get 900 megabits whenever I run speed test, and your throughput test shows me only getting 200 or something like that. So it's a common enough question that I thought that we would talk about it a little bit. So I'm going to talk about the websites and how they work, 7SIGNAL's throughput test, talk a little bit about TCP slow start and throughput versus test length. And Jim, I'm sure you probably get these questions from our customers as well.
Yeah, it's a very common question. Very common question. So it'll be very informative, I think, for our audience today.
Let's get on with it. First one that I want to talk about, and I picked these two, speed test and fast.com, just because they're the ones I usually hear about. They also seem to report the highest speeds most of the time. So I did a little bit of digging, and there's a couple of links down here if you want to go follow up and read their full description. But a few things, kind of came out about how they work, and they're both pretty similar. The first one is they do not run a single connection for that download. They'll break it up across multiple connections and add those values together. Speedtest.net says they use up to 4 simultaneous connections to download. Also, the test runs fairly long. I timed it on myself. They don't say on their website, but it seems to run about 15 seconds. And it plays around and tries to do everything it can to improve the throughput. So multiple, as I said, multiple connections. It's going to play around with buffer sizes and how much data it requests and sends during the test to really maximize that throughput. In fact, their goal that they say in one of these documents is to use enough data to flood the internet connection and measure the full capacity of both the network connection and the device. So they're really trying to slam that connection, push every byte through it, and make the biggest number that they can. They make a big point in their documents to say that they are doing it the right way, and kind of any other way to measure it is not accurately measuring the throughput. And I'm sure you've probably used these websites as well, Jim.
Yeah, for sure. It's a useful way sometimes just to get a point in time measurement of the absolute max network capability when you're using internet-based services, just to kind of see quickly, is there a significant slowdown somewhere between me and the internet. Now, one thing I'll add to that is that often these servers are hosted not out in AWS or GCS or on the internet backbone, but actually in the central offices of major ISPs. So sometimes, and probably more often than not, you're really measuring the performance from your device to the internet service provider and their data center.
Yeah, and in fact, the next one, and I don't have quite as much on this one. They just don't have as much documentation, but I do have a link for you here. They make the point that they use the Netflix CDN to host those speed tests, and those Netflix servers are definitely hosted very locally all over the world. It's important to them that they they can provide a lot of bandwidth to a lot of customers. So yeah, they definitely make the point that they're testing to a local-ish site. And they actually, they don't give quite as much information even as SPEEDTEST, but they do say that they run up to 8 connections during the download to try to flood that, and they'll run for a long time. They run up to about 30 seconds. So it just stands on the connection for about 30 seconds. And in fact, in their reporting, they ignore the first part of the test that usually runs a little bit slower to try and report the fastest speed. And in fact, this down here in the corner is my connection at home. Whoops. It's supposed to be a 45 megabit DSL connection. I get 49 or 50 from fast.net, and looks like about 44 from SPEEDTEST. So they're I think pretty close to measuring what the maximum of my connection is. But as I said, those are the two that I hear about most. There's a lot of other SPEEDTEST websites. Not all of them use multiple connections. In fact, some of them in their documentation will point out that they don't use multiple connections, and will turn SPEEDTEST argument that they're the only people that can measure it accurately around on them, and say they're not really measuring it accurately because they are using multiple connections. I think, it's really up to us to understand what these test sites do and what they're good for, and maybe not necessarily listen to all of their hype. But sort of in conclusion, on these SPEEDTEST websites, they'll run multiple simultaneous connections. They'll do long test runs. They pull every trick out, like I said, adjust buffers and request sizes to try to max out or flood that connection. And they simulate large file downloads, torrent downloads pretty well, because that's what you're doing on those types of applications. But they really don't reflect web browsing or email very well. And finally, they have a big impact to the network whenever they're running the test. So if everybody in an office is constantly running these SPEEDTEST websites, it can actually put a hurting on the network. What do you think, Jim?
Yeah, that's right. Particularly the longer duration tests, 30 seconds, and I think just observing how end users use these sometimes, they run it over and over and over again sometimes. Oh, that's too low. That's not right. Maybe it was just a momentary disruption. Let me run it again. And
in an office, hey, Bob, I'm only getting so much. How about you? Pretty soon you can have everybody in an office running the test.
And then everybody gets poor numbers because everyone is running it at the same time, and that makes them want to run it even more. It can spiral. Yep.
But it is good for finding out if you're getting, at least in raw connection terms, what your ISP told you.
Yeah.
Looking at our speed test, the 7SIGNAL HTTP download test, it's a really different sort of test. We only use a single download stream. We only run for 2 seconds. And it really simulates web browsing where you're fetching lots of small files usually. On a web page, there'll be, if you ignore the ads, there'll maybe be a dozen small JPEGs and some text and that kind of thing. So it's a lot of small downloads, but we don't simulate downloading large files very well. That's, it's just something that our tests don't simulate. But the ultimate point is that we want to be able to make consistent measurements over and over again, and we don't want to put too much impact on the network under test. And whether it's Sapphire Eye or Mobile Eye, it isn't just one person running the speed test. It's a bunch of people. They're only running it every few minutes or sometimes few tens of minutes. But whenever you get a lot of devices on there, you have to worry about the network impact. So that's really one of the big reasons that we keep this test short. So you really need to understand that. What do you think, Jim?
Yeah, that's, I think that's exactly right. This is a great test for measuring what most internet or network traffic really looks like, while also having a pretty light impact on the network while it runs. So,
Yeah.
But you can obviously see we've made a lot of different decisions in how this test runs compared to those public services.
Yeah, absolutely. And we actually do support running longer tests. We don't support running multiple streams, but you can tune the test time if you want to run for something other than 2 seconds on our tests. But that seems to be a good number for us. So I want to talk a little bit about why it matters. Why is this so important? And a big part of it is the TCP slow start. And if you think back about how TCP congestion control works, the basic idea is if you're missing ACKs, then you reduce the amount of bytes allowed in flight or the amount of packets in flight. And slow start sort of starts out pessimistic. So it will send a small number of packets, 1, 2, maybe 3 or 4, and wait for those ACKs to come back before it sends any more. And then as it gets those ACKs back, it will allow more and more packets in flight, that is transmitted but an acknowledgement not received. And it's going to continue cranking that up every time it receives ACKs until it either reaches the maximum window size that's set on the server or until it starts missing ACKs or having delayed ACKs. In which case it's going to close that window down, it's going to reduce the amount of packets it's allowing in flight, and then sort of gradually let that ramp up again. And there's different algorithms that are part of the congestion control. It's a little bit out of scope, but slow start always seems to work basically this way, where you send one or a small number of packets, you get the ACKs back, you increase, you get the ACKs back, you increase, you get the ACKs back, so that you allow more packets in flight. Did I make that clear, Jim, or was I more confusing than harmful?
No, a great explanation. I mean, if you've ever wondered, how does my computer know how much data it can send, how much throughput it can consume when it's connecting to, something out on the internet across a lot of hops, across Wi-Fi, across where there's bottlenecks? How does it know, how fast it can go end to end with that connection? This is the protocol that it uses to determine that.
Yeah, exactly. So I wanted to follow up a little bit on this. This is a graph that you can produce from Wireshark. It lets you graph the sequence number, which is really the number of bytes transmitted, is what it sort of ultimately comes down to, against time. And you can see here, this is a connection starting. And here at the beginning, you'll see it's just transmitted just a few packets, just a few sequence numbers. And then we've got this 50 millisecond delay. It's about a 50 millisecond round trip time to whatever it's talking to. And it sends a few more packets because they got the ACKs back. And then this long 50 millisecond wait and a few more packets. Another long wait and a few more packets. And And very gradually, and as we go up, it's total bytes transmitted. So it isn't speed, it's total transmitted. We can see that we're starting to get a little bit steeper up here. But you don't really get to the point where you don't have these breaks where you're waiting for ACKs on this 50 millisecond connection until about 0.4 of a second. So almost half a second into the transmission until the windows really open up and you're basically continuously transmitting data. And that's really the heart of why TCP connections start out really slow. What do you think, Jim? I'm sure you've seen this.
Yeah, and this is really useful when you think about so many connections being used just to send a small amount of data. You know, the protocol may not have windowed all the way up to the maximum amount of packets it can send before it's already received all the data it needs or sent all the data it meant to. So in some cases, you know, I think this is one of the reasons why, you know, in some cases UDP is preferred for very, very small packet exchanges, even though, you know, there isn't a retransmission method built into the protocol. You know, adding all this overhead and dealing with this, you know, waiting for ACKs is unnecessary sometimes. Just a little aside there, but
yeah, especially for real-time applications, where, I mean, if you think about it, the server's just sitting on its hands waiting for ACKs during these gaps. It's not doing anything but sitting there waiting. So if you're trying to do something real-time, and usually you think of voice or video, but it could be you know, machine monitoring or something like that. TCP is usually not the way to go. Great for transmitting big files, though.
yeah,
Easy because it does all the error checking itself.
yeah, and just to bolster that case, you know, TCP is a very old protocol, and a long time ago, networks, especially the internet, was really unreliable, and you had to deal with a lot of packet loss, and you needed TCP to retransmit those lost packets and make sure everything's acknowledged on the other end. And
Yeah.
you know, that's not as big of an issue with today's networks and the internet and the state it's in today. And so, you know, in many cases, UDP is better because you don't have to deal with that overhead anymore.
Yeah. And remember, even with UDP, you can always wrap your own reliability protocols around that. And it's easy for me to say since I don't write code anymore, but you know, that is something you can do. Is you can use UDP and then do whatever retransmissions you need to yourself. And I think I've got mostly graphs from here on. Fast.com actually had some really nice graphs of sort of their ramp up, and Fast.com, they vary the amount of time the test runs until it sort of stabilizes. And you can see here a low latency connection, you know, it starts up and it ramps up kind of slowly, and then they measure out here, and a higher latency connection ramps up a little more slowly, and they make the connection out here. And if you notice, I think that's 24 seconds out on the far end, so it can potentially run long tests. And then I really like this one. This one I actually pulled from one of our customers. I went and found a customer with just a beautiful internet connection. To a nearby server, they were 980, 990 megabits per second on a wired connection, and the Sapphire Eye does do wired connections as well. And I didn't show the higher throughput connections here because it was basically flat. It started out at like 940 and eventually ramped up to 960 or 980. So it didn't show much change with a 1 millisecond to our sonar server and the internet. So, I mean, I think that says what a good connection they have. But I tested all of our sonar servers around the world and picked a couple to sort of show real world what that looks like. And remember that these guys have a gigabit plus connection. They're running 900 plus megabits per second to local servers. And all of our sonars have really good connections. That's part of what our system group does when they site sonars is make sure that they have good, fast, high bandwidth connectivity. And you can see, this is the red line is a 248 millisecond latency, and that's from New York, which is where our test point was, to our APAC server in Singapore. And the blue line is to one of our European servers at about 79 milliseconds. But you can see the difference between the 2 and 6 and the 6 and 10 are pretty big. We get big step ups in throughput whenever we go those longer test times. But then as we get out to the longer connections, the growth is not as fast. I think this graph is also kind of interesting in pointing out that it's not just latency. I could let this run all day and it wouldn't get much faster, even though both ends have got more than gigabit connections. There's just so much in between, so many links, some of which are, I'm sure, oversubscribed. You know, the best that they're going to do from New York to Singapore is about 30 megabits per second, even though both ends have got excellent backbone connections and very high speed. I don't know if you've seen this graph, Jim. What do you think?
No, I haven't. I have seen similar studies though that have shown how in some cases, particularly as latency increases significantly, TCP will not use anywhere near the full available bandwidth, network bandwidth, I should say, end to end, because of the latency sensitivity. So that's where, like you alluded to earlier, there's been some research and some new algorithms proposed for improving TCP to kind of meet the network conditions that are more typical of today's networks.
Yeah, in fact, there's a lot of work done on the TCP congestion control algorithms. There's a lot of variations on that. Slow start, as far as I know, doesn't really change much. You have to start easy because you just don't know. But yeah, there's a lot of work done in TCP congestion to, so especially whenever you drop a packet to try to ramp the bandwidth back up again, because it does close the window down. Normally, congestion control closes that window down when it loses a packet. I am gonna add one more thing that I didn't do a slide on here, and I didn't because I don't have enough data, but I did want to mention it. We talked at the beginning about multiple streams versus a single stream, and the rest of it I talked about really latency and slow start. And it's just because I couldn't find really good data on how much difference running multiple connections makes. I did some testing myself on my connection, and obviously at a 45 megabit connection, it's really not typical, I think, of a lot of the speeds most people have. But I saw about a 20% speed difference between single stream and multiple stream on the testing websites that allow you to choose. And other people reported as much as 35 or 40% difference between single stream and multiple stream on downloads. So I don't know what the numbers really are. I don't really know what affects it and what the important variables are. But I think saying between 20 and 40% difference is probably justifiable. I don't know if you have anything to add on that, Jim, but that's all I've got for today.
Yeah, great. Yeah, thanks, Mike. And I think we got a few minutes we can spend on Q&A. So if anybody out there in the audience has a good question they want to send in, send it our way. A couple questions around, what we think of some of the various other throughput testing protocols and services out there, like what Tamisoft does. I see NPerf mentioned, a few other things there. And I guess my take on it is, use the right tool for the right job. So it all depends on the context and what you want to discover with that test, and understand what it was built for and what its intentions are. And if that matches up with your needs, then that's the right tool for the job.
Yeah, the iPerf, NPerf, whatever, those tools are great because they're really configurable. You can configure the buffer sizes, you can configure the number of connections, and you can really dial those in to support whatever it is that you're trying to measure. And I think that's important. What is it you're trying to measure?
Absolutely. So comment here from Anders. This might be useful for the audience that wants to get into the nuts and bolts of TCP. He says TCP has some extensions from Van Jacobson's et al. To scale the transmit window size, etc. And there's an RFC about that. So it specifically improves throughput on long latency connections. So thank you, Anders. If anybody wants to go out and Google that.
Yeah, it's a hot improving TCP's congestion control.
So Mike, here's a question from Mark. He says, for 8 to 11 connections, do you ever compare speed test results with throughput test results inside the network? On the LAN, I assume he means.
Well, we do make our throughput tests inside the LAN. Our Sonar server, which is the test partner in our test, is freely available. So most of our customers will install their own Sonar server on the LAN so that we can make those low latency connections that are not affected by the internet. But the Sonar server doesn't really support speed test style connections so we can't do the comparison there.
Yeah, maybe one last comment here. I got a kick out of this from Michael when we were discussing kind of the contagion that happens when there's bad speed test results. He says, yeah, it's sort of like a stop replying to all email storm. If you've ever been in a big company when that happens, oh, what a disaster.
Yes, nothing like everybody replying to all saying, take me off this list.
Yes.